abilities lies in it being entirely electrical, as opposed to more conventional weapons fired using explosives. The railgun can be broken down into three basic parts: an electrical power supply, two parallel metal rails, and a conductive projectile. The power supply is made up of numerous capacitors that slowly store up energy gathered from other energy sources. This provides the electrical energy necessary to turn the rails into electromagnets. The two rails are what give the railgun its name. Their purpose is to create electromagnetic fields which accelerate the projectile down their length. The armature must be a conductive material such as aluminum so that it will contain a charge. That way it will complete the circuit of energy flowing through the rails. The sabot is a cradle-like device that carries the slug until it leaves the gun. The slug is the only part of the projectile that hits the target. This electrical energy is then passed along each rail individually. Once the projectile is inserted between the rails, it completes the circuit. This allows power to flow from the positive terminal on the power supply up the positive rail, through the projectile, and back to the power supply through the negative rail. This current turns the rails into electromagnets, which create a magnetic field by means of the moving electrical current. Each rail then has a magnetic field circulating around it in opposite directions. This causes the field between the rails to be directed upwards, lifting the projectile. The electromagnetic field, along with the current being passed through the projectile, exerts a force, known as the Lorentz force, which accelerates the projectile along the rails away from the power supply. The projectile at a right angle to the direction of the magnetic field. As of now, the railgun is still in the testing phase, facing many obstacles before it can be used outside of the lab.